Oh, hey, Hedgie, what's up?
Hey Ben, I need some help.
Come on in. What's the problem? What's the issue?
I'm having a lot of trouble with dynamic memory and all this pointer crap.
Alrighty, show me what's up. I'll come take a look. Oh boy, that's fun.
Yeah, I just can't get it to work. I think I'm really struggling on the whole concept of dynamic memory and with new and it's so confusing.
Yeah, the concept can definitely be difficult at first. To the Board of Helpfulness! Alright, so before we tackle dynamic memory, I want to make sure you have a good handle on pointers. So, what is a pointer?
They point to numbers, right?
Yeah, close. A pointer points to data. It points to an address in memory. So, picture like here's your computer and here's your memory. Your memory is basically just a big row of boxes, right? You've got boxes that can store, numbers. They can store bytes, bits, ones and zeros. And each box has a number. So 0, 1, 2, 3, 4, and 5. And it keeps going on and on. So, let's say you write some C++ code, right? You say int a. This tells the compiler that you're going to need room in memory to store an integer variable, right? So when it gets compiled, it's going to choose, an address in memory and choose to store a there. Now I can't choose 0 because nothing can go on in 0. So let's say it chooses to put a right here. Let's say you did a equals 1, or int a equals 24. So it's going to put 24 right here, and it's going to know that this represents a. Now if you want a pointer, you do like int star pointer equals the address of a. And so really just this pointer is just another integer, and it points to 1, which is the address of a. And this number also, since it's just an integer, they're all just numbers, it gets stored in memory as well. So right here, let's say this is pointer. So you could have a pointer to pointer as well. You could do int star star like pointer 2 equals the address of pointer. So you can do that. You can point to, that just points to address 2. So here's pointer 2, and its value is 2. So they're just integers, which is why you can do pointer arithmetic, like pointer plus 1, and then you can dereference that. And dereferencing, it's really just telling the computer to say, hey, what is at this address? Give me the data that's at this address. So you could do anything. You could do star 69, and that would give you the data that's at address 69. Probably not what you want, but it'll do that. So that's pointers. We good on that?
Yeah, okay, I get pointers, but what the hell is up with all this new and delete stuff?
Okay, yeah, so dynamic memory. There's two types of memory, right? There's static, and there's dynamic. Static memory is determined by the compiler at compile time. And dynamic is at runtime, while the program is executing. So static memory just reads from your code. So if you have an int a, b, and c, let's take this. The compiler is going to know, hey, I need to make room for 3 integers, and they're called a, b, and c. So I'm going to go ahead and store them at 1, 2, and 3. 1, 2, and 3, right? So let's say they're all equal to 0. Now, this also works well if you want like an array of integers. Let's say you want, I want an integer array of 5 integers. So remember, an array is just a pointer. So if you have, for instance, let's say it starts here, r would be equal to 4, and then you'd have your 1, 2, 3, 4, 5 bits of data. Now, what if you want to do a vector sort of thing, where you don't know how many elements you're going to have ahead of time? It's unknown. You need to use dynamic memory. So there are two places in your memory where data is stored. You have the stack, which is for static memory, and you have the heap, which is for dynamic memory. So think of it just like two big boxes in your memory. Here's the stack, and here's the heap. So when you compile this program, your int a, b, and c, you get some values, a, b, and c. Now, let's say at some point in your program, you realize that, hey, I want a new array of 5 integers. You basically write that in plain English. You say, hey, C++, give me a new integer array with 5 integers. And what this does is it will allocate memory in the heap. So basically that just tells the operating system, hey, operating system, I want space for 5 integers. Give it to me, please, now. And so the computer says, oh, okay, so this is used up, and this is, you can have, here, take this one, here. So here's space for 5 integers. And like any address or any place in memory, it has an address. So this beginning spot, let's say it's like 72. So that's the pointer. It's going to give you the pointer to this new block, this new chunk of memory. So when you do this, let's say like int star array equals new int 5. Then array is going to be equal to 72, because it's just a pointer. Now say we're using it for a vector, and we need to increase the capacity of our vector. So we say, okay, now I need a new integer array that fits 10 integers. So you say, hey OS, give me space for 10 integers, and it says, oh, okay, you use this, and somewhere along the way this got used up, you can take this chunk here, right? So this one also has an address. Let's say it's at like 134. So now you say like int star, or not, you don't redeclare it, I'm sorry. So just array equals new int 10. And behind the scenes, you will receive the number 134. Now we have a problem, because these 5 integers here are still floating here. The computer doesn't know what to do with these. You didn't tell the computer to get rid of these. So it's just like, I'll hold on to these. It's cool. I got this. So you need to tell, before you do this, you have to tell the computer to deallocate or free this memory. So that's why you have to do delete R at the end of everything. And this is only for like dynamic memory, not for static memory. So to review, like static memory at compile time and stored in the stack. Dynamic memory is at runtime, and you use new and delete to get stuff, and it's stored in the heap dynamically. So does that help you at all? Are we good?
Yeah, that helps a lot. Thanks, Ben.